So before we start, I'd like to thank you, everyone. Thank you, BEEES, and thank you particularly for helping with my otherwise tough schedule. Actually, from that point on today, I'm unusually relaxed, so I don't really mind about time. I don't know about you guys. And slides over there just to drive discussion, so I would rather make this interactive. Haven't I done that?
I don't,
No, it's not.
Well, the red,
Can you see?
or maybe it's my phone.
so that red sign out here should be, it's being shared. Yeah, it is shared. Let me do it again. Okay. Good. Well, as I was saying, all these slides here are just to help having a discussion. And I would really like it to be interactive. So thank you again for having me here. And well, I'm here to talk about, well, I prepared the slides based on my CV so that they are, following a time order, what I've done. And I suppose that the topic is to just interact with you and you ask questions about why I took decisions the way I did and how I ended up here. Okay, is that?
Yeah.
Good. All right. Working. Murphy's Law. Things work fine up until you need them. Okay, anyways, doesn't matter. Okay, a few things about me. I'm somebody that you can always find at this room. Well, that's not actually true. Most of the time when I'm in this building, I'm in room 402. But there's also a place called Smart Unit Lab, which is on the ground floor on the other side of the building. And this is where I do part of my research, most of my research actually, with all of my colleagues, postdocs, PhD students, and other academics. And I also work for something called BDFI. BDFI is an institute, which means that so in the hierarchy, it stands at the top. Smart Internet Lab along other labs are members of the institute, so they all form this institute. And within each and every lab, like Smart Internet Lab, there are smaller groups. I belong to HPN, which stands for High Performance Networks. So my research is about networks. I'm a lecturer, and to be more exact, I was hired to do artificial intelligence for digital structures. So that pretty much says what I'm doing. And my research is aligned, as I said, with Bristol Digital Futures Institute and the Smart Internet Lab, which means, I hope you can see that. From one side of things, what I do can be described as zero-touch edge and cloud networking. This means more or less that we used to have a network and some administrator, some human administrator. They would just put policies, they would define how things work. Pretty much like if there is a network packet that comes from this part of the network. I want it to travel to the other half of the world, and the next step should be from this guy there. Why? Well, because of my policy. I know that he or she is going to charge me in a desirable way. Or we frequently exchange data, so at the end of the day, we charge one another the same amount of whatever that is, money. So I don't pay the other day. But things have changed because networks are very, very complex, and because your services that you run, like imagine virtual reality, or as you move with your mobile device, they're very demanding, which means that decisions, if they're static, they won't work for each and every scenario. Worse, you need to take decisions not within minutes or seconds. We're talking about milliseconds, sometimes even nanoseconds, like autonomous vehicles. Otherwise, someone's going to die. So that's why we bring AI into the picture, not because it's more clever, but because things can run faster and hopefully efficient. We're not there yet. That's why we do research on that. That is on the one hand. I work on something called edge and cloud. Pretty much that means the edge of the network is whatever is very close to the user. So if there is an access point here, I cannot really find any around here. It should be somewhere hidden around here. Like a Wi-Fi access point, that is part of the edge of the network. You go through many devices called routers, and then at some point you find yourself in a big room where you have a lot of devices over there, a lot of hardware doing the hardware of the network, and that is probably the cloud. We call it a cloud for a very good reason, because if the service that is serving you right now, like Facebook, or by saying Facebook, I also include Instagram and everything else that Facebook has. You don't really know which server is really serving you right now, or it could be more than one. That's why it's the cloud. Okay, and all these things, along with Internet of Things, like devices like sensors or industrial IoT, industrial sensors, they all fall within something called 5G and beyond 5G or 6G. You know, all these things are marketing terms. They are not really technology. And if anyone tries to define to you what 5G is, they're probably going to tell you what it's supposed to be, and we're not there yet. And if they try to explain to you what 6G is going to be like, well, there are no standards. Like, there is no organization that has decided that we're going to call this 6G. What they're going to tell you is flappy words. They want to make it 100 times faster. 100 times, not faster in the sense of having a bigger bandwidth, more information over time. More responsive, which means very, very, very fast in the sense of how much time it takes for one bit to be transferred from one part to another to the next. We want to utilize part of the wireless spectrum that is at the order of gigahertz. By the way, in 5G, we say we're doing gigahertz, they call it sub-gigahertz or whatever. It's not already there. Terahertz, sorry, it's sub-terahertz. Okay, these are the technical things, but in BDFI, we actually do blend social sciences with technology, which means that you got socio-technical problems, like in the future society. If you cannot guarantee that everybody has seamless access to network services, you're going to create people which are illiterate. Actually, I don't even know why I'm saying in the future, because right now, can you imagine somebody without access to the network? They are actually living in an environment which is not just 10 or 20 years ago. You're living as if you never knew how to read and write. Yeah, so this is how you need to define some policies. And one policy could be, how can I make access seamless? And should it be seamless in the sense that everybody can play a video game? I don't know, I'm just asking here. Or if you start charging so that you make sure that whoever consumes more pays more. What if a very rich guy comes and say, okay, I'm going to play part of this virtual reality game in Millennium Square, but I'm going to afford it, so I can take all the resources. The rest of the players have nothing, or very little yet, which is cheating. And all of them together, they might be harming NHS in case there is some incidents and they need to take resources. So these policies at high level, okay, that's only one example out of many. And you can start throwing terms here like equity, equality, seamless access. What else? The so-called key value indicators can quantify and start measuring how good you are in this. These policies have to be translated to actual network policies, how the network assigns resources so that whatever you intend to do in theory happens in practice. So we translate the so-called KPIs, key value indicators, to key performance indicators, KPIs. Okay, that's the big picture. Sorry for that. So I have worked in several research projects funded by either the UK government or the European Union. Some of them are funded by industry. The way that things work is usually that there is a public call, and What you do is that you apply based on the call, along with others in a consortium, and you try to get money. As simple as that. Or, especially with industry, if you have peer directly, you've got a good relationship and they trust you, it can be more direct. Okay, you can form together that problem, research problem you want to solve together. And previously, I have been funded by the French and the Greek governments for having worked there. But you probably know me because I teach here, and I teach a year 1 unit, which is called Digital Circuits and Systems. And because I also supervise junior researchers at all levels and students for their thesis, their projects. Okay, that was the boring introduction. I hope the rest of it's not going to be boring. I got a question for you, and let's try to make it more interactive. Are you here because some of you dream of doing research, academic research or more applied, or you're just interested in an industrial career? Let's start with the ones that want to do research. We got 1, 2, 3, 4, and 5. Okay. And what about the industry? I suppose it's the rest. And anyone that hasn't made up their mind? Okay, then I've got good news for the ones that haven't made up their mind. You cannot decide to be a research in industry. In what we do? In engineering and computer science. It's not a fun science. It's a tough one. It's not about defining a new concept and a new idea in the sense of, no, it's about defining a new concept. It's more about, instead of speculating, let's make it happen. Which means that you work very closely with the industry. There's only one big difference here. You're working as well as they do, perhaps even more sometimes, and you're being paid less. Now, why do you do that? Well, because you're given the option of defining your own research. Now, imagine working at Facebook. It's perfect, or in Google. They have been working with ideas like on machine learning and things like virtual reality and whatever. There's something these days called containers, which I'm not going to define in a different way other than saying that if you know what a virtual machine is, it's a software that emulates a real machine, a real computer. A container is something even more advanced. They've been doing that, God knows since when. That's why they had their cloud facility before anyone else in Google. And then at some point they made open source because obviously they don't care about it. Meanwhile, if you were doing research there, you could not publish it. The world is never going to find out that your ideas have actually formulated that thing called a container. You see? So it's not that you're completely free, but you have more options. And it's about the academic life, if you like. Or that at some point of your life you realize you made a wrong choice and there's no way back. Okay, so what I've done in life. I studied basically computer science and informatics. Not that enough in Greece. So I'm not an engineer. Not at all. I'm a computer scientist, which means that I have done my studies on things like distributed systems, operating systems, systems coding, also analysis of things like not just learning a programming language, but what is the concept of a syntax in the programming language? How does the computer work as a conceptual goal? But not the chips, not the microchips. I've been doing engineering. And at the same time, because in Greece, all programs are mandatorily 4 or 5 years, I also did informatics, which is not exactly the same thing. You do things about information science. Highly theoretical, or like when it comes to databases, you don't just learn the technology, but if you want to design a database, what do? You go to the business and you try to understand what they want from you. Usually they don't even know what they want. Or how do you take something from real life, like all of us here in this building right now, and create a mathematical model or any model that describes it so that then you can translate that into code. Okay, why am I saying this? Well, at the same time, I worked as a junior software engineer with Java. I was developing for a couple of years. I found it particularly boring, so here's the thing. I really like programming, but because of the fun of it. Imagine like somebody that plays football and doesn't want to become pro. You're asking why would you want to do that? but there is a main difference. Professional footballer, if you're really good at that, you'll make a lot of money. If you're really good at coding, but only coding, there's a ceiling that you're going to reach at some point, you're going to stop there. Which is why guys like Elon Musk stopped coding years ago, or Bill Gates. Now, of course, this is a very bad example. People usually talk about the very successful cases. We should be talking about this guys actually, because they are out in this world. Not because they're brilliant, but because they have the right connections. Like Bill Gates was from a really rich family, and his mother actually got him in touch with people that invest in his ideas. He was super lucky, so that IBM would pay him something, him and his colleague, he would create it, and then they wouldn't buy it, so they would sell it and make it competitive. Mark Zuckerberg was in MIT or something like that, I don't remember. So he already had connections. There were social networks before Facebook. Steve Jobs was going to all these research centers. He would take those brilliant ideas from very, very clever people, and then he would just commercialize them. He was brilliant at that. So all these people, they were unique cases. Do not have them as a paradigm for your future career, because each and every one of you is different, and because they are out of this world. So I didn't like coding. That's the thing. And it was good that I worked while doing my studies, because I realized that I enjoy what I do for fun. I won't enjoy it when somebody comes and tells me, there is this box on the web page that is not rendering well. Right, fix it. So what I did is that I chose to do a thesis that back at the time was very interesting. Machine learning back at the time, up until, and artificial intelligence, up until 2013 or 12, was something that was a really good idea. In the 80s and the 90s, people were expecting that everything's going to be like we do now with machine learning, but let's put it this way, it wasn't feasible. The computational resources would never be enough. What's changed is that we had these graphics cards that do very quick interest multiplications. Although they were created for graphics, they made whatever we had for decades in some drawers ideas feasible to do. Now, back at the time when I did my thesis, it was still at the point of time it's fun, it's not feasible. I did something called named entity recognition, which means that you give it texts and it automatically discovers that this is a token that refers to a human being, this refers to a place, an organization, it refers to a text, and whatsoever. And when I finished my thesis, I published it, which was a lot of effort. I worked even after finishing my studies. I did it for fun, but I knew that even though I enjoyed it and I was good at it, I should have probably tried something else, which made me jump into doing a master's in distributed computer systems. Back at the time, real computing, cloud computing was the next big thing. There was something called peer-to-peer networks. You could illegally download content from them. And I really enjoyed this. And I jumped to distributed computer systems, which was completely unrelated. So it was more like throwing away all of my background at that point. Databases, informatics, artificial intelligence, although all these things match well together. Like imagine automatically extracting entities from a text and putting them on a database. Okay, so I did it because it was systems oriented and I liked it. And back at the time when I started finishing, I realized that it was at its height and was about to end. So I did a PhD on something that was again different, but it would allow me to use ideas from distributed systems. My PhD was on something called information-centric networks. Imagine the networks that we have today. You probably haven't been taught about them yet. ICN was trying to make a network work in a way that is not about, it's not like having a phone network. Today, the internet works essentially like a phone network. If you want to communicate from one point to the next, you essentially use an address. It's like calling somebody. ICN would work in not a magical way. You would just search for what you were looking for, and whoever had it around you as valid information, they would pass it to you. Which means that you wouldn't have to go to the United States to print something. You wouldn't have to even go to your local internet service provider. If somebody had next to you, you would save resources and you would immediately take the service. Content, service, whatever that. Unfortunately, that isn't feasible. And I lost the bet because back at the time there was something else called software-defined network, which won the competition, and this is what I'm doing right now. So it sounds like a failure, and it was a series of mistakes, but I was lucky because all these dreaded things, distributed systems, my experience with ICM and machine learning allow me to work today on something that combines networks, artificial intelligence, and distributed systems. So there is this notion of luck, and if I would like to give an advice to you, whatever decisions you take today, you don't know if it's going to turn out to be a good decision in the long term or not. There's always, you have to be lucky or just avoid being unlucky. And what I'm doing right now, which is software-defined networking, is something which is very fashionable. It looks like it will prevail. It is prevailing, actually. 5G workspace with this. And there is a lot of, let's say, economic motivation and policy motivation from your providers. What is the definition of SDN in one paragraph or in a few sentences? Well, up until now, you used to have dedicated hardware, specialized hardware that would do something like routing packets on the internet. This would mean that if you owned one of these devices, you would be jailed or close to this vendor, like whatever vendor that would be. I don't like naming things, but it would be Nokia for life, and then they would blackmail you. The way that usually works, even in real life, in everyday life, I sell to you something in a value of 1 because then the service costs 100. And then they will start charging whatever they want. Now, the concept of SDN is that you don't have dedicated hardware. You have generic hardware because today's hardware is very good. And whatever was the service that is specific, the function that a specific hardware would do, you do it in software. Even better, you do it in so-called open software, which means that there are no property secret things. Open. The interfaces of the calling, they're open. So if I don't like one implementation, I throw it away and I another one. Or I can get really fast machine, a very, very good machine, and have 10 virtual routers. Pieces of software. They're not literally machines. They're all virtual, and that's why we call them these days virtual network function. But all this flexibility, as you can see, makes things very, very complicated, because besides you as users moving around, becoming functions that jump around. And why do they jump around? Because they will provide a better service in one part of the network if they move over there. That's why you've got AI in the picture taking decisions. Okay. So it's not about just research. We work together with companies. Okay. Would you like to ask any questions so far? I was hoping to be more interactive. Like, do you have any question? Yeah, go ahead.
Yeah, I was advised by my tutor said because I tried for it very start last year and I got one, and he told me that was like a detriment to my TV, but it's not really going to be very useful as time with that. So I'm just going to ask for advice because I would love to do research, but I might start an accident. So I think doing an industrial, we have 2 years. Very
Okay, so I need to know exactly what this is to comment that there are things that will certainly not look nice in CV, okay, and things that are going to look neutral and things that are going to look really, really good. To be honest with you, what counts as what is exactly going to do next? What the next step will do?
industry.
Industry. So doing an internship usually is a very good thing, and not just any internship. Doing an internship that is technically what you would like. If that would be, for instance, virtual reality, do something in graphics. This is something that's related to user mobility, work on mobile networks or on or on a project that involves a network simulator, because it might not be a product itself, but this is where people try ideas before trying them or test them. I don't know, is this answering your question?
Yeah. I know.
And yeah, and it's the thing about things that look bad in the CV, for instance, if somebody jumps and changes from one topic to the next very, very quickly, that's not a good thing. If somebody stays for too long in some area, it would be good, but at the same time, you know, it's like somebody that doesn't exercise. If you sit on a chair all the time, you will get adapted to that, and you will be very difficult for you to switch to something else. So finding an optimized and balanced solution is not easy. Do I spend 3 or 4 years in one job before jumping to the next? Probably this is part of time. Do I spend the whole of my life in the same institution? Probably not. Do I do my master's studies if I choose to go to the same university? I think that if you just jump to another institution, forget about the superstore. If you go somewhere else, you learn, I mean, if it's about the same things, you learn something different. You hear things from different people. And perhaps the structure of programs is different. If you work for a company and then you jump to another one, the big challenge is that you need to adapt. But at the same time, you gain more experiences. If you stay in the same institution, the same industry, whatever, it's very convenient, but then if something happens, you are fully dependent on them. You've learned all the technologies that they care about, nothing else. And it could be outdated because like banks really like to use things that work and they know they work for the last 50 or 60 years. They would really love you to know Fortran and COBOL, programming languages that nobody used after the 1990s. Unless you want to work for NASA. Okay, that's a different story. Any other questions or anything to discuss?
Might be stupid.
Oh, that's not stupid.
Wouldn't ICN be a security risk if anyone can do still the sources of their findings?
Well, this is why it's not an easy thing. There are ways of ensuring that nobody's going. Actually, it was more privacy sensitive than current networks. Current networks starting from the phone network. So security and privacy and accountability and everything else is an add-on, which is why it's being violated. One of the main design objectives was how to make things private, like in today's internet. If I route one packet from you to move via him, he knows the packet came from you and it goes to me. If it's a more multiple thing, every node in between routing the packet knows where it came from and where it's going to. One of the main concepts of ICN was that everything would be encrypted and the whole path would be encrypted in a way that each and every node in the middle knows that this packet came from that node, and I'm going to forward it to the next node. I do not know the whole path. So that's a way to make it perhaps sensitive. But that doesn't give good accountability. So if I'm prosecuting or doing things legally, how can police find that? Well, there has to be a central authority that everybody must trust. So these were not actually problems. The real problem is that only web pages back in 2010 or 12, they were 10 to the power of 13. That's probably more than the number of stars. The number of information is infinite, and not only that, each piece of content or service changes in time. You get one page, web page with news, on the next day, something completely different. How do I know that whatever I do is not outdated? So we're talking about humongous numbers. That thing would never scale. It can scale within an institution like the University of Bristol or a city, but it would never become the world. But you see, that was a research question. So you look like you like privacy, if I'm right, I don't know. Good. Anything else you'd like to discuss? What about, for instance, I suppose being students, you want to know how things are in life. I don't know, it's about traveling, yeah.
How hard is it to get funding for research?
It's very hard, it's very competitive. Unlike other sciences, there is a lot of money, but there is a lot of interest and a lot of policies in that, which means that you have to compete with a lot of people, and that's why you unfortunately have you ever heard about the Zipfian law? So, according to the Zipfian law, and you see it being applied in real life everywhere, 20% of, I'll take my example, 20% of the videos on YouTube are actually account for 90% of video watching. If you take a random part of the stars, 20% of the area has 80% of the stars, the surface, and the rest of it is almost a gap, the black gap. And again, on research, it looks like the most successful institutions and the most successful researchers get most of the money, probably because they got the best ideas, or if we want to be realistic, sometimes about how you sell it. And just like in real life, if you've got money to invest, you get more luck. If you either by luck, or because you're capable, or because you're both, or because you're reckless. If you make a good start, then one step brings the next, and then before you know it, you're huge. And then you're doomed because there's only one way, becoming larger and larger and larger. The moment you stop becoming large, you collapse. Just like IBM. IBM was actually the company that created computers. It was huge. It was a giant. Up until the 80s. Some mistakes led to the company stop growing. Imagine Google today, which is a giant. If Google one day stops growing, it will probably start shrinking. And it will probably become like IBM. Maybe some of you don't even know what IBM is. We have computers today because of IBM. So this is how research works. It's very competitive. And yeah, you just need to create the right network of people. I'm not talking now, I'm not really implying a corrupted system here. I'm just saying that the right network of people, it's a network of people that are going to hear about your ideas and they know how to assess it or how to fund it. So it's 100% effort and 100% luck at the same time.
What are red flags for the that you were produced for the study research?
Okay.
Yeah.
So for me, a red flag back at the time on artificial intelligence was that it wasn't visible and that I could work only on banks, only bank systems would have it. And you would optimize, you know, the optimized algorithm for deciding whether or not to give loans. Back at the time, everybody would give a loan because the system was corrupt and they would take more money back in bonuses. So it was a red flag for me. But it was a wrong idea. Like, here's one mistake of mine. I thought that because it was invisible based on the current technology, that I shouldn't do it. And I could have proved right actually, because up until today, if it wasn't about these CPUs and GPUs, the graphic processors, I would have still been the same thing. So by now, I would have been somebody that had a career that was very difficult. But my fundamental mistake was that I took a bet based on what is visible. When it comes to ICM, I know that it isn't visible as an idea. Be careful, I'm not saying it was a wrong choice of mine. I learned a lot about it, and parts of it are ideas that can work on an application level, perhaps not as part of the network. It's good to design a software system where I know that I can immediately find what I'm looking for by quickly routing on virtual nodes rather than actual routers. I know it's very obscure, but the thing here is that if you make any choices, better, especially the red flags, better be sure that it's something that is really, really a bad idea. If it sounds like not a sexy idea, then I get no answer. It depends on whether you like it or not. So what is perhaps the thing that you like the most? Do you have anything you like the most?
Yeah, satellite.
Satellites are going to be there forever.
I know. Yes.
And it looks like things are becoming very, very sexy these days. Not just because Elon Musk invests in that, but because they actually,
You know, the factor.
things are So the cost of satellites becomes lower and lower. Oh, and that's another good implication by SDN. When you would throw a satellite in orbit, you know that you would have something that would be there for 10 or 20 years, that it would be outdated technology in the sky, that it would be too expensive to replace. What happens now that you shoot on the stars? Smaller satellites, more cost efficient, with blank hardware, and you can update the function, something that you were not, something that you could not do in the past. So yeah, work on satellites, it sounds like a good idea, but it's a very broad thing. You have to decide exactly what you want to call it. It could be 5G or 6G networks for satellites, could be military, it could be e-health.
And really want to make the correct choice, and that's why I asked previously about the red flags.
I don't see any red flags in satellites, especially right now. I never saw red flags, like, okay, on optical systems. I don't really see a red flag here, but I see that research has come up with a very mature product, but very difficult to improve it, which is why you see also funding getting reduced on that type of research. But there's a lot of money now, so if you like to take a bet and you want to do something really sexy, which I do not know if it's going to become feasible or not, it's quantum computing. In almost 100 years, but now things start to get more pragmatic. Or quantum security, which is a little bit more feasible because you don't want to do computations, you just want to make sure that you know when somebody is tampering or is eavesdropping or whatever. And again, you won't see a product probably within the next 30 years, but there is a lot of funding now. It is a bet. We know that in theory it can happen. We know it's not invisible, so there is no red flag here. There is, let's say, a yellow card. Because it's a personal bet. But the thing is that if you do research on that, you learn so many things about physics and networks at the same time that you can easily jump to something else. Like I jumped from distributed networks to ICN and then to SDN. Okay, very quickly. I worked, as I said, as a code monkey. I hated it. I was a teaching assistant, just like many of you have probably been during my PhD years and later on, in France and in Greece. And then I ended up here, which I like, and since 2020. So when I went to the Netherlands to do my master's, it was nice. I traveled a lot, and then I did my thesis, my bachelor's and my master's thesis, and I had the opportunity to publish them, so I did travel by somebody else paying for it. And then I did my major, my first really good presentation as a PhD student. I thought I looked like that, while in what people tell me probably looked like that. And I traveled in places of the world that I normally wouldn't afford back at that time, like traveling to Australia, one of my 2 favorite places I visited. So all that to present something, okay, I did a lot of work to have my paper accepted so that I can go there. But it was worth it. And I also work in France, which looks like every other part of the Mediterranean, but it's really cold, believe me. We're not smiling there, we're cold, me and my friend. And then I also traveled to Japan and Tokyo, which is my second most favorite trip, another world. And today I'm here in Bristol, and these are colleagues of mine, Dr. Rashid Hussain, and another one that's Sophie, you probably don't know because she's from different departments. Software development. And that's it. I don't know if we are done. Whatever you want. As I told you, these slides are here just to accommodate the discussion. I had other pictures as well, which are not appropriate for an academic member to share. I can only describe it. Like, when you're students and you go to some dormitory, a lot of things can go really, really nice and wrong. Usually funny. I don't like drinking that much, so I never go. I only got tips in my life. Maybe the cultural thing. Greeks drink in order to for fun. If you get wasted, you then, if you do it once and then you regret it the next day, you don't want to do it again. So I was usually, yeah, I was actually making a lot of good fun. Have fun. Yeah, these are years that you'll never live again because you don't want to live with many people for the rest of your life. It's fun when it lasts for a little. It lasts for a lifetime. But at the same time, when you're students and you prolong, so when you're a PhD student, you're not really a student. It's a 100% dedicated job, okay? But at the same time, you somehow are a student at the same time. It's this gray area. When you are an academic for the rest of your life, you are both a student and somebody that works at the same time. That's the bad thing about research, by the way, and a good thing. You can never say that you know something. It's being updated. Not like you're an accountant and you know how things work, how the system works. Or if you study law, some fundamental ideas stay there, just like in computer networks. But okay, let's say that laws not change as frequently as technology do. And the concepts. And that can make things very tiring at some point. So yeah, nothing is perfect. And you cannot go out partying for the rest of your life. Yeah. Because at some point you need to create distance to the student. Long story short. You wait until they got you. Okay, you tell me about bees. And why do I keep seeing bees everywhere and I don't know anything about it? It's not because you're not sending emails, it's because I don't have time to read them. Are you all members of bees here? And you're not all year one students, as far as I can understand. So what is bees about?
It's the Bristol electronic engineering. That's
Okay, I know, but what do you do? Do you go out? Do you have pizza all the time?
Actually, yeah, we have events in pizza. We have like movie nights, more formal events, pub quizzes. Yeah, and like voting this type of talks. We also have robot wars. So like students can make their own robots and like basically compete with each other.
Pretty cool. Okay, so you are a society that does what usually American societies do, but not the other part, the one that they have made it with, bench. Oh yeah, I've been in California once and I saw some Greek letters and some buildings, and I was like, okay, that's interesting, why do they have Greek letters? The moment I stepped in, I saw somebody. Let's put it this way. I saw somebody as if he was just born, and I was like, okay, I'm out of here. What's falling up next? You don't do that. Or you don't talk about it. Okay, so anyways, if you don't have anything else you would like to discuss with me, I really enjoyed this talk. So honestly, I want it to be more interactive. But if you want to discuss anything with me, drop an email. I'm not fast in responding usually, but I do respond. Okay? Yeah.
Very traffic stuff here. What the companies you actually do?
So I cannot hear you, but I have to come.
The other companies you actually work with doing your research or still doing your research.
Repeat that because I want to be sure I had.
Actually, companies.
Oh, I do work with companies all the time, especially after coming here. So here's the thing. You got governments that they want to create an area of research, and they won't do that because they believe in that or because they want to, for political reasons, to invest in something. And then you got companies that, so here's one thing, they can actually give you funding, like we were paid by Samsung to do a project for them. And it was a public project, which allowed us to make publications come out. And why, so you wonder why would Samsung wouldn't want to do that? Well, because it's politics. When they invest in one country, they want to show that they invest also in open source. Okay. Not just to make money, you would send something back to the society. Very few companies want to do that. And we're working very closely with Thales to do it. But besides their own funding resources, sometimes governments or supranational organizations like the EU, they announce that I'm going to give you money in a public call as long as you come up with a consortium that includes both academics and industrial partners, which is ideal in engineering and in computer science and in non-profit sciences. I cannot easily think of other types of research that you would include companies in. Because to be honest with you, they would probably fight that. Like, I cannot really imagine a company like Thales that builds military technology or guards borders with somebody from social science that would probably, from my experience, want to not do that. Right.
Thank you for.
Now, I would like to thank you all. And yeah.